Imagine this. A star explosion so immense it could wipe out all of New York City, parts of Connecticut and New Jersey. This incredible scenario revolves around one of the greatest mysteries in astrophysics. Betelgeuse, a magnificent celestial giant that has captivated astronomers for ages. Recent updates from the renowned physicist Michio Kaku have sparked concerns, suggesting that Betelgeuse may have finally detonated. If true, this explosion would dramatically reshape our understanding of stellar life cycles and the forces that shape the universe. But what does it mean for us? Stay tuned to find out. Picture yourself gazing at the night sky, noticing a bright star in the constellation Orion, Betelgeuse, also known as Alpha Orionis. Orion, a well-known star cluster, lies at about 5 hours 30 minutes right ascension and 0 declination, its name tracing back to the legendary Greek hunter. Recognized for its reddish hue, Betelgeuse ranks as the 11th brightest star globally, with a magnitude of 0.6. In the Orion constellation, Betelgeuse stands out as the most prominent, shining as a beacon on Orion's shoulder. The name Betelgeuse originates from the Arabic term Bat al-Jawza, meaning the giant's shoulder. In 1603, astronomer Johann Bayer named the star Alpha Orionis, marking its status as the brightest in the Orion constellation. However, despite the current brightest star being Rigel, Betelgeuse proudly holds onto its title. Betelgeuse is a colossal star, about 20 times more massive than our Sun, making it a giant in comparison to our solar system. To put it in perspective, if the Sun were the size of a small marble, Betelgeuse would be a massive basketball. Estimating Betelgeuse's distance has been a challenge, with calculations placing it between 500–600 light-years away, a vast distance in cosmic terms. Despite this, Betelgeuse shines brightly, with a luminosity rating around 6 times greater than our Sun. According to Harvard University researcher Morgan McLeod, Betelgeuse's proximity and size make it one of the few stars that scientists can closely study with telescopes both on Earth and in space. Telescope images of Betelgeuse reveal a surface unlike our Sun's smooth appearance. Instead of a uniform sphere of hot plasma, Betelgeuse's surface appears as a collection of uneven boiling gas pockets, some of which are as large as small stars. Massive eruptions of hot material rise from Betelgeuse's core to the surface, resembling cosmic spring cleaning. One of these shells is so immense that traveling at the speed of light would take 75 years to cross it. This process, known as surface mass ejection (SME), expels material from Betelgeuse's outer layers, similar to the Sun's coronal mass ejections. However, Betelgeuse and the Sun have different internal structures and processes. Despite being a relatively young star at only 10 million years old compared to our Sun, Betelgeuse has already burned through its hydrogen fuel and is now in the later stages of its life cycle, transitioning into the red giant phase. During this phase, Betelgeuse fuses helium to produce carbon, demonstrating a rapid evolutionary journey fueled by its significant initial mass. Scientists believe that Betelgeuse began its cosmic journey as a blue-white type star, belonging to the most massive class of hydrogen-burning main sequence stars. In the realm of stars, size directly correlates with brightness and heat. Larger stars like Betelgeuse shine brighter and burn hotter, but this also leads to faster hydrogen consumption and an earlier transition to the red giant stage. Betelgeuse's surface once reached searing temperatures of up to 89,500 degrees Fahrenheit, a stark contrast to our Sun's relatively cooler 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and began fusing helium, its outer layer expanded significantly, making it one of the largest stars known, stretching over 700 million miles in diameter. Despite its cooler surface temperature of around 5,800 degrees Fahrenheit, Betelgeuse outshines the Sun by a staggering 7,500 to 14 times. In 1836, astronomer John Herschel noted fluctuations in Betelgeuse's brightness, leading to its classification as a semi-regular variable star with periodic changes and occasional irregular variations. Typically, Betelgeuse follows a 400-day cycle of brightening and dimming. However, an unusual event occurred in 2019 when Betelgeuse deviated from its regular behavior, dimming by about 60%. This marked a significant departure from its usual pattern, caused by a massive material ejection that formed a vast dust cloud, obscuring our view. Although the dust cloud has since dissipated, Betelgeuse hasn't fully returned to its previous state, and its 400-day brightness cycle has shortened to just 200 days. This unpredictable behavior has sparked discussions about the possibility of an imminent supernova explosion. In such an event, as Betelgeuse burns its remaining fuel, its core would collapse, giving rise to a black hole while expelling its outer layers at speeds of up to 25,000 kilometers per second. If Betelgeuse undergoes a supernova explosion, it would be an extraordinary spectacle, visible for weeks like a second full moon in the night sky due to its proximity of only 650 light-years. While star explosions are common, they are often too far away to be seen without powerful telescopes, making Betelgeuse's potential supernova a breathtaking event for skywatchers. As stars evolve, their cores accumulate iron, eventually triggering a supernova. The most recent observable supernova, supernova 1987A, occurred in 1987 at a distance of about 168,000 light-years. This event, visible to the naked eye, provided significant insights into stellar evolution. The last recorded supernova before that, observed by Johannes Kepler in 1604, outshone all other stars in the sky, even during the day, though it had no significant impact on Earth due to its vast distance. Betelgeuse, now at the center of attention, is expected to go supernova. Miguel Montarges, a Betelgeuse expert, predicts that when this happens, Betelgeuse's brightness will rival that of the full moon. Imagine a mesmerizing 2-month period where, on a clear night in a dark city, you could read a book illuminated by the glow of Betelgeuse's supernova. In 2021, the star's mysterious dimming episode sparked widespread speculation, but its fate remains uncertain. Will Betelgeuse soon explode, marking a new era of cosmic understanding? Betelgeuse recently experienced a notable dimming event, similar to the 2019 phenomenon, where its brightness decreased by around 60%. This dimming was attributed to a cloud of material in the star's wind, which obscured part of its surface, particularly the southern hemisphere, as seen in images. After this darkening, Betelgeuse unexpectedly brightened by 50%, and the cause of this sudden increase in brightness remains a mystery, sparking speculation among astronomers. Betelgeuse, a red supergiant approximately 15 to 20 times the size of the Sun, is expected to eventually undergo a supernova. Although astronomers generally predict this explosion will occur within the next 100,000 years, a recent study by Hideyuki Seo and colleagues from Tohoku University suggests that the star might be in a more advanced stage and could explode sooner than anticipated. However, there are differing opinions on this conclusion. Seo's team bases their assertion on Betelgeuse's pulsating behavior, as the star regularly expands and contracts. While they do not foresee an imminent explosion, they suggest it could occur within the next 1,000 years, challenging the longer timeframes previously considered. The uncertainty surrounding Betelgeuse's supernova timeline has captivated astronomers. Some researchers argue that stars like Betelgeuse can endure for over 10 million years, a brief period in cosmic terms, but an eternity for human observers. As scientists search for clues about when Betelgeuse might explode, they examine changes in its color. Historical records describe the star's color as similar to Saturn's yellowish hue, rather than its current reddish tone, raising the question of whether Betelgeuse's color has changed. If so, it could indicate rapid stellar evolution, suggesting a supernova might happen sooner than expected. This color shift provides insight into the star's transformation, aiding astronomers in interpreting cosmic events. Whether Betelgeuse's supernova happens soon or takes its time, humanity will have a front-row seat to witness this extraordinary stellar event. But what would happen if Betelgeuse did go supernova? The idea of a supernova visible from Earth has fascinated many. New simulations help astronomers understand what we might see when Betelgeuse finally explodes, which is expected within the next 100,000 years, though uncertainty remains. At a distance of about 500 light-years, Betelgeuse is far enough from Earth that its supernova is unlikely to have major impacts. Research indicates that a star would need to be within about 150 light-years to produce significant effects on our planet. Approximately 26 million years ago, a similar event may have contributed to a mass extinction affecting marine life. If a supernova occurred within 30 light-years, it could have more serious consequences. However, Betelgeuse's explosion is not expected to pose a threat to life on Earth. The explosion would release a burst of ultraviolet radiation, which might cause a temporary reduction in the ozone layer. However, studies suggest any resulting ozone depletion would be minimal and short-lived, with limited environmental consequences. Soon after the explosion, we would detect neutrinos, weightless particles that are harmless to us. Betelgeuse would then quickly brighten, reaching a luminosity comparable to a full moon within weeks. Over the next several months, its brightness would gradually fade, remaining visible in our sky for about 6 months to a year. As night falls, it would continue to be a spectacle for another 1 to 2 years before fading from view entirely. Unfortunately, Orion would lose its iconic red glow, which would live on only in memory. Regarding potential dangers to Earth, supernovae emit powerful particles known as cosmic rays, which can penetrate Earth's magnetic shield. However, aside from the closest supernovae, the amount of cosmic radiation from Betelgeuse would likely be minor compared to other forms of radiation we already experience. The supernova's grand finale would not only captivate us but also release radioactive elements like iron, a cosmic signature found in Earth's ocean sediments and even on the Moon. This iron, born from a supernova 2 to 3 million years ago, was just 300 light-years from us, yet posed no significant threat to life on Earth. Fortunately, such nearby stellar explosions are extremely rare, possibly occurring only once in a billion years. As speculation swirls around the potential appearance of Betelgeuse's supernova, astronomer Andy Howell from the University of California wanted more precise answers. To achieve this, he enlisted the help of 2 former graduate students, Jared Goldberg and Evan Gross. Their detailed simulations vividly depict the star's epic finale, acknowledging uncertainties while drawing insights from observations of supernova 1987A, the nearest recorded supernova in recent centuries. These astronomers concluded that while life on Earth would be unaffected, the cosmic display would not go unnoticed. Goldberg and Gross found that when Betelgeuse explodes, its brightness will resemble the gentle glow of a half-moon, shining about 10 times fainter than a full moon. This mesmerizing brightness is expected to grace the skies for over 3 months. Further studies estimate that Betelgeuse is approximately 724 light-years away, well outside the potential danger zone. However, the supernova could still have fascinating consequences for Earth. Howell points out that many animals rely on the Moon for navigation, and they might be confused by the appearance of an extra-bright celestial object. Astronomers would also face challenges, as the intense brightness would overwhelm telescopes and space observatories. To adjust, telescopes would need to capture the subtler, softer glow of the supernova. Experts assure the public that there will be ample warning if Betelgeuse unexpectedly goes supernova in our lifetime. Earth's instruments would detect signals such as neutrinos or gravitational waves generated by the explosion, giving us up to a day's notice before the event. Though this event is unlikely to occur for another 100,000 years, Betelgeuse will eventually become a supernova, and the outcome will depend on the materials that remain after the star's grand finale. As we anticipate Betelgeuse's potential supernova, scientists continue to refine their predictions and deepen their understanding of such stellar phenomena. Observations of similar stars at different stages of their evolution provide crucial data for modeling the life cycles and eventual explosive deaths of massive stars. This information helps astronomers assess the frequency and impact of supernovae within our galaxy, contributing to our broader understanding of cosmic events and their implications for nearby and distant celestial bodies. The study of Betelgeuse and other supergiant stars also aids in calibrating cosmic distance scales. Accurate measurements of these stars' luminosity and behavior improve the techniques used to determine distances to far-off galaxies, thus enhancing our overall mapping of the universe. Additionally, supernovae play a vital role in understanding the synthesis and distribution of heavy elements like iron and nickel throughout the universe. These elements are crucial for the formation of planets and life as we know it. Meanwhile, space observatories are closely monitoring Betelgeuse and similar stars, using cutting-edge technology to detect any signs of imminent change. These efforts ensure that we are prepared to witness and study one of the most spectacular events in the universe's life cycle, deepening our knowledge of the dynamic processes that shape the cosmos.